Here we have x squared minus 9 quantity squared y double prime plus x plus 3y prime plus 2y equals 0. We want to determine the singular and ordinary points of the given differential equation and classify each singular point as regular or irregular. Let's begin by determining the singular and ordinary points. Okay, so we want to begin by setting this term to 0. So x squared minus 9, x squared minus 9 equals 0. So add 9 on both sides. You have x squared equals 9. Square both sides. You have x equals square root of 9. So x is equals to a positive or a negative 3. Okay, so let's put our singular point right here. Singular point at x equals 3 and at x equals negative 3. Then we have an ordinary point at all finite values unequal to the singular point, which is x equals 3 and x equals negative 3, which you can write it as all finite values unequal to 3 and negative 3. Okay, now let's find the singular points. Let's classify each singular point as regular or irregular. Begin by setting this to standard form. So let me write this: set to standard form. Divide x squared minus 9 quantity squared on all terms, which you have figured out 2 minutes ago that you can factor this out to be x plus 3 and x minus 3. Okay, squared. All of this. Does it really work? We can try factoring it out. We can try distributing. So you have x squared plus 3x. This is supposed to be a 3. Okay, x squared plus 3x minus 3x minus 3 times negative 3 is 9. So this cancels out. You are left with x squared minus 9. Okay, so moving on, you have y double prime plus x plus 3 over this value, which is x plus 3. You can distribute the power, so x plus 3 squared and x minus 3 squared y prime plus 2 over x plus 3 squared and x minus 3 squared y equals 0. So find your p of x and q of x. P of x will always be y prime, so this is p of x. Q of x will always be the y term, so this is q of x. Q of x. Now you want to find the power of these terms. So you can cancel these out. You are left with 1, the power of 1 for x plus 3, and power of 2 for x minus 3. Now, does this condition hold true for p of x? With p of x, we need the power to be less than or equal to 1. For x plus 3, the power is less than or equal to 1 because the power is 1. So x equals negative 3. This holds true, okay? Moving on. X minus 3 to the power of 2. 2 is greater than 1. So for the point x equals 3, because this does not hold true, we know that it immediately classifies as an irregular singular point. Okay, irregular singular point. Now, we still need to test if it holds true for q of x. So x plus 3 squared, the power is squared, which holds true. So okay, the condition is true for x plus 3. And for x minus 3 squared, the power is squared. 2 is less than or equal to 2, so holds true here too. But because it didn't hold true for this is an irregular point. And because it holds true for this as well as this, x equals -3 is a regular singular point. So here we have our classification.